we will be seeing how to perform a post-order traversal in a binary tree. What does post-order traversal mean? Is the pattern that is going to get followed when we are going to traverse the children on the left subtree and the right subtree. First, we will be visiting the left subtree. After visiting the left subtree, we will then move forward to the right subtree. And now the definition that says post order. Why it says post is because after you visited the left subtree and the right subtree, then you go towards the root. And this is the pre-order for traversal, which is left, right, and then you visit the root. How that translates into an example is something like this. So let's start with this as my root node. I will first go towards the left. On the left, I don't see any node or any subtree associated with it on the left side. So I have covered the left side. Then I move forward to the right side. The right side is this node. Now, even for this node, which is in the right subtree, I will first visit the left subtree. So then again I will go and I will visit the left subtree. For this node, then the left subtree has a node which is 3. This doesn't have any left node or a right node to visit. So this we just pick it up. And the order now becomes 3. After which we will then see if there is a right node. The right node doesn't exist. And after that, we have to go to the root. So in this case, after going to the right node that doesn't exist, the root is 2. So the next node in the sequence is going to be 2 because we covered the root part of it. Now we have covered the entire right subtree, and the order was first go on the left side for the root node, then you go towards the right subtree, and then you come back to the node which is going to be this root. And for this, the order is displayed something like this: 3, 2, 1. And that's how post-order traversal mechanism works. Now let's convert whatever we covered so far into code in JavaScript. We said the order is strictly going to be left, right, and then the root node itself. And to do that, we will just say we want to return as outcome an array from a function which is going to maintain the sequence of this traversal. So in the end, I'm supposed to return the array, and in this array I said I want to first visit the left subtree. Now this function for post order traversal is going to visit root nodes. First root node is going to be 1, then it's going to see on the left side there is nothing, and then it's like going to go on the right side, because first we have to go on the left, then the right, and then you come back to the root node itself. And on the right side you see this node. Now then this node will become the root node for this right subtree, and this can go in a recursive fashion. So what we will say is recursively go first towards the left subtree that you have, and that will just be something like root dot left. After going towards the left subtree, I now want to go to the right subtree. So the first is left, then I will go to the right subtree, and to do that I will just say make a recursive call to the right subtree, and in the end I want to visit the root itself. What does visiting the root itself mean is I will pick the value of the root and just return it in my array, and the value that is supposed to be written is just going to be root dot value, and that needs to be returned. Now we said we want to return a array. If I do a post order traversal here and then I return an array, this will be returning an array of arrays, which is not what we want. And because of that, what we will say is I want to get the results, spread it, and then return. So this way I won't have nested array within my array. It will just be a single level array, not a 2D array. And now we need to add a exit condition, because for recursive functions you always need a exit condition, otherwise it will go in an infinite loop. When do I want to exit from a specific iteration in this case? So I'm going to keep on going through all my nodes, and let's say I reach here for 3. I want to go towards the left, but on the left side I don't have anything. I want to go towards the right, there also I don't have anything. So when you don't have anything, it means it's null. And if the node itself is null, because we are going to call root.left, so in this case it's going to be null. And we are also calling root.right also, which is also null. And to handle that, we will just say if the root that you have itself is null, then I want to return just empty, and this empty will then get returned here. We spread it, so nothing comes out of that empty array, nothing comes out of that empty array here also, and you just return that specific root value itself. And that's pretty much it in terms of implementation. Now, in terms of the complexities that are going to be involved here with this recursive approach, the time complexity is going to be big O of n, where n is the number of nodes that we have received, because in the worst case you have both the left subtree and the right subtree, and you have to traverse the entire tree itself, wherein the n stands for the number of nodes in the tree. And in terms of the space complexity also, it's going to be big O of n. Why big O of n? Because every time you make this recursive call to this post order traversal function, it's going to occupy space in the call stack. And in the worst case, you can occupy for all the nodes that you have received within this call stack. That's why the space complexity is going to be big O of n, with n being the number of nodes you have received. And that's pretty much it. Thank you for watching. Please like and subscribe.